Let's build a deep neural network which we have seen in last video. As a first step, I'll import the Torch library and then I'll also import the torch.nn package. So import torch.nn as nn. And then I'll define the number of units in each layers. So number of units in input layer, hidden layer, number of units in output layer, and the batch size is equal to 10, 5, 1, 10. And then I'll define the x and y like this. X is equal to torch.random, and inside the parenthesis it is batch size, number of units in input layer, and y as outputs with zeros and ones like this. Like I have shown in the last video, we will build the model. That is, model is equal to nn.sequential, and inside the parenthesis we will define the layers. So nn.linear, which takes number of neurons in the input layer and number of neurons in hidden layer. And then activation function, that is nn.relu. And next it is nn.linear, wherein number of neurons in hidden layer and the number of neurons in the output layer. And finally it is nn.sigmoid. So this has completed the model, and now we will define the loss function from nn module. So it is loss function is equal to nn.msc loss. So we will then create the optimization algorithm as stochastic gradient descent from torch.optim package and pass in the variables inside the parenthesis. So optimizer is equal to torch.optim.std, and inside the parenthesis it is model.parameters, lr is equal to 0.01. Till here we have learned in the last video itself, but now let's create the loops. For I in range 25, and inside the loop I'll first compute the y hat, which is nothing but predicted output, and it is given by ypred is equal to model x. That means we are passing the input values to model. That means we are passing the input values to model to compute the predicted output. We then compute the loss, and we get the loss by passing the true output and predicted output to loss function. So it is loss is equal to loss underscore function, and inside the parenthesis it is ypred, y. So guys, this completes the forward pass. Now we call the backward on loss value. So it is loss.backward. Now observe very carefully here. In the last section, we had updated the parameters individually inside the loop for w and b respectively. And if we follow the same process, then that means we have to write the loop for each variable. Instead, we simply call as optimizer.step. And this step function will update all the parameters. Okay. Once this has updated the step, we then set the value of gradients to be 0, as we did in the last section. So it is optimizer.0grad. Yes, this will clear the gradients of all the optimized tensors. And this will go on until the number of loops is completed. Now what I'll do is, I'll add a print statement after computation of loss with the epoch number. Okay, this is done. I'll now execute the code. So we now have the results. Yes, we have got the results. And I hope you now have understood as how we make use of Pytorch to write neural networks in Python with just few lines of code.